get this on here. So yesterday we talked about one special type of triangle. Do you remember what it was? What it was? Yeah. Oh, let me get my writing thing. There we go. Okay, so yesterday we did a 45, 45, 90 triangle. So let's, what? Well, I don't know what I'm supposed to do about that. Those two lengths look about the same?
Yeah.
Pretty close. I think that bottom one might be a little bit longer, but it's close enough. All right, so just a quick review. If these two sides are equal to each other and it's a right triangle, then I have a 45, 45, 90 triangle, right? Because remember, if both sides are equal to each other, the opposite angles are going to be equal to each other. So that means this angle right here and this angle right here are equal to each other. And we also know, since it's part of a right triangle, that those two angles add up to be 90 degrees, correct? And if they both add up to 90 and they're both exactly the same, then what must they both be? Anybody playing along here? 45 degrees, okay? So there's your 45, 45, 90 triangle. I didn't write this down yesterday, and I was thinking about it, and I should have. One of the first things I should have written down, but I didn't, but I'm going to do it today. Remember we said if this is 1 and this is 1, remember if this length is 1 and this length is 1, what did we come up with as far as the hypotenuse? Do you remember what that was? It was the square root of 2, correct? What if this was a 3 and this was a 3? Then this would be what? 3 square root of 2. If this was a 5 and this was a 5, this would be 5 square root of 2. You with me? So basically it's this. The hypotenuse is equal to the square root of 2 times one of the legs. Doesn't matter which leg. No, because what's true about both of the legs on this type of triangle? Both exactly the same. So there's a little formula, I guess, if you want to call it a formula, that we know about a 45, 45, 90 triangle. We took a whole period, talked about that yesterday. I'm not going to do any more, but that's what we learned. Everybody with me so far? All right. If you weren't here, or if you were asleep, or you just weren't paying attention, go back to the YouTube video. It's up on YouTube, and you can watch it. Good. Let's do another type of triangle. So let's make this stay straight up and down. Again, I don't know. I'm just kind of eyeballing it. But it probably looks something like that, be my guess. And that. Okay, it's a right triangle. But now, these two sides definitely are not equal to each other. So we can't say it's 45, 45. Would you agree? But what if I told you that this was 30 degrees? What could you say about this angle up here without me saying anything else? How much? 60 degrees. That's right. Because, remember, these two angles, if this is in a right triangle, the two acute angles are complementary. What does that mean to be complementary? They add up to be 90 degrees, okay? They add up to be 90. So if this is 30, then 30 and 60 add up to be 90. Everybody with me on that? That worked with the 45, 45, 90 too, didn't it? Okay, because 45 and 45 add up to 90. All right. On this one, we have a hypotenuse, and this one right here would be the hypotenuse. How do I know that that one's the hypotenuse? It's opposite the what? Which angle? The right angle. Okay, they're all sides are opposite some angle. But right, the hypotenuse is opposite the right angle. Everybody got me with that? Okay, we've talked about that before. Now, this leg and this leg are two different sizes, right? They're two different lengths. And, one's going to be smaller, one's going to be bigger. So we call one the short leg, and we call the other one the long leg, all right? So we could say smaller, bigger, but we don't. We say short and long. So which one of these is going to be the short leg? It's pretty obvious. The one that's opposite the what? The smallest angle, exactly right. Okay, so if this is the smallest side, it must be opposite the smallest angle. We learned that a long time ago when we first talked about triangles, okay? So this one right here would be the smallest side. Or what do we say we call it? We don't call it small, we call it short, okay? So we call this the short leg. Technically, it's the shortest leg, all right? What do we call this leg right here then? Is it the medium one? If that's the shortest one, hypotenuse is always the longest leg. Or I shouldn't say leg. It's always the longest side, okay? So what do we call this leg right here? Remember? The long leg, right. So I call this the long leg. You can put leg in here if you want, but I'm just going to put short and long. Everybody good with that? Now, I could go through and show you how we get this stuff. And I think the first time where I taught this, I don't think I even did it then. I got it in my notes. If you're really interested, it's in the book as well. You could always look up YouTube videos. And I think I may have, if again, maybe one person in here would be interested in seeing this, but you could always go to the honors geometry class. And I'm pretty sure that I showed how we got this next thing, all right? But with you guys, I'm just going to show you what we came up with, all right? You can just believe me, all right? You can watch the video if you're that heartbroken over it, okay? Which somehow I don't think you are, but now there's a relationship. Now watch, everybody watch this. There's a relationship between the hypotenuse and the short side, and there's another relationship between the long side or the long leg and the short leg. See what I did with those arrows? That's really important, okay? So the hypotenuse, there's a relationship. Is it twice as big? Is it 3 times as big? Is it half as big? What is it? What is the hypotenuse? What's the relationship between the hypotenuse and the short leg? Do you remember what it is? It's 2 times the short leg. So it's 2 times, so it's exactly twice as big. The hypotenuse, that's the longest side of my right triangle here, okay? It's exactly twice as big as the short leg. Now, this is only true on a 30, 60, 90 triangle, right? Let's write that at the top here. 30, 60, 90. So if I had a 20 and a 70, right, 90 triangle, that's not true about that, okay? It's only true on a 30, 60, 90 triangle. Everybody got that? That's why they're special. That's why they give you a whole lesson just for these 2 types of triangles, because they're special. They stand out. There's certain relationships. So the hypotenuse is exactly twice as big as the short side. So what if I said that short side right there was 3? What's the hypotenuse going to be? It's going to be 6. Everybody see that? Simple. If I know the short side, hypotenuse is super easy. You just double it. That's all you do. So if I would have drawn this correctly, which I doubt it, I could have taken this side right here, stretched it to here, and then another short side would stretch all the way down to here, and they would add up to be exactly that hypotenuse. Does that make sense? Okay. I don't know. I'm just curious. I kind of doubt. I mean, I'm probably close, but let's just see how close I was. I think I can do this. Yeah. We'll try to get it to match up. That's pretty close to straight. Yeah, that's pretty close. I'll tell you what, let's put this in a different color. Yeah, I think I was off a little bit because that one looks longer than that, doesn't it? Copy, paste. So I was off a little bit. Well, I was off quite a bit. So I didn't draw it exactly right. But technically, if I would have drawn it exactly 30, 60, and 90, then what would be true about this short side? This would be, right? See, I had that big old gap right there. So I wasn't very accurate on drawing this, but that's okay. I told you at the beginning I probably wouldn't be exactly. So if you wanted to, watch. If I wanted to make sure that it was exactly the same, let's change this back to white. What could I have done? I could have, well, it would be kind of hard actually to do this because I don't know what angle to make it. Anyway, forget that. Let's just stick with this. Sorry about that. All right, so there's one formula. Now, on a 45-45, there's only one formula to remember. Okay, on this one, on 30, 60, 90, there's actually 2 to remember because you've got the hypotenuse, and it relates to the short side, and you have the long side, and it relates to the short side as well. So let's write this down. So I'm going to say the long side is equal to something times the short side. It is. It's the square root of 3. Now, how in the world did we get square root of 3? Well, if you really, really want to know, actually, let's do that. You all right with that? Let's do it. So watch. Again, I'm going to, I'll just show you where that square root of 3 comes from. Again, I'm just kind of eyeballing this for 30, 60, and 90. This can still be 30, 60, 90, even though it's smaller than that triangle. Would you agree with that? Right? The angles, just because the lengths of the sides are bigger, doesn't make any difference. So what if we'd said this? What if I said the length of that was 1? Now, let's try to find the other two sides. This is 30, 60, 90. Okay, so that's 30, and that's 60 right there. So what's the easiest side to find? If I know one of the sides, okay, and this one is 1, how could I find one of the other sides? Let's do the hypotenuse first. Can you tell me what the hypotenuse is if I tell you the short side is 1? It's 2, right? You just double it. So that's pretty easy, isn't it? Do you agree? Yeah. So how in the world would I find the longer side now? Let's call it L for long. What would I do? Forget this formula right here. I'm trying to figure out how in the world did you get square root of 3? Where did I come up with that number? Did I just pull it out of the blue? No, it actually works out this way. Because watch, what if this side was 1 and this side was 2, right? Because it's double the short side. How could I find the L? Something that we've learned how to do already in this class. And you might have learned how to do this in Algebra 1. It's a name. It's a theorem. I'll give you a big hint. It's a theorem. Pythagorean theorem. That's right. Because you got a right triangle. You got 2 sides. I could find the third side. So how do I set up the Pythagorean theorem? It's 1 squared plus what?
2 squared.
No. Where does the 2 have to be? Remember, it's a squared plus b squared equals c squared. The 2 has to be the c, right? The hypotenuse. So it's got to be 1 squared plus what? L squared. I call it L. Equals what? 2 squared. So let's see what L is going to be. All right? And this is where they came up with this square root of 3. Again, they didn't just pull it out of the blue. All right? They came up with this formula right here, and they figured it out. What's 1 squared? It's 1. L squared, we're just going to leave it L squared. What's 2 squared? That's 4. Do you see where the 3 is coming from now? Because you subtract a 1 from both sides, right? Bring down the L squared. 4 minus 1 is 3. Where did they get the square root from? No, we already set the Pythagorean theorem up. Look, this is L squared. How do we get rid of that squared? We square root it, right? Square root that side, square root this side. Look what you got. So what's L? It's the square root of 3. Okay? So if the short side is 1, the hypotenuse is twice as big as the 1, and the long side is the square root of 3 times the 1. You with me on that? We just made it easy by making this side 1. It just made things look real nice and easy. So what if the short side, so let's put that in a box. So now we know where that square root of 3 came from. All right? I mean, that's kind of nice to know, isn't it? I mean, it's not earth-shattering or anything, but it's nice, because we throw a lot of formulas out and you're probably thinking, I don't know, maybe you are, maybe you're not. But at least I did. I was like, well, where'd they come up with that? Who in the world figured out it was a square root of 3? That's such a random, weird number. Why is it the square root of 3? Well, this is why it's the square root of 3, right here. Everybody with me on that? Okay. Yeah, that's good enough for that. Let's do this. Let's do just a little bit of an example. Tell you what, I'll just stick with this triangle right here. I'm going to give you the easiest version of this. Yes. Yes, of course. I almost thought you had a real question for me, but I should have known better. All right, what if this was 5, and I asked you to solve for x and y? Go ahead and do that. You should be able to do it in your head, tell you the truth, but write it down. Write down what x is and write down what y is. Everybody do this. Everybody should be able to do this now. And it should be pretty easy. You should just be able to do this in your head. You don't need a calculator or anything like that for this. So the short side is 5. How did I know it's the short side? Just because it looks shorter than the other ones? Nah, don't go by that. Go because it's opposite the 30-degree angle. So that's the shorter one. This is the hypotenuse because it's opposite the right angle. That must leave this one is the long leg, okay? What's the first one you're going to do? Really doesn't matter. All right, let's do the hypotenuse. That's kind of what we did over here, all right? So let's do the hypotenuse. So the hypotenuse is how much of the short side? Let's double it. That's right. So what's y? It's 10. Pretty easy, right? And that was the hardest part of this whole problem. The long side is actually the easiest part of this problem because you don't really have to do any math. All you have to do is take the short side and do what to it? Multiply it by the square root of 3. So what is the short side? It's 5 times the square root of 3. And that's how we write it. Okay, don't put this into a calculator and get some decimal number for it. Just leave it like that. That's an exact answer. Okay, that's what math teachers want. They want you to write the answer like this. Okay, they don't want you putting it into a calculator. Now, when you become an engineer or an architect or a scientist or something like that, and you're going to have to use square roots, then you're going to start putting that stuff into a calculator and get a decimal approximation, right? Because in the real world, that's what you do. But in the math world, at least for us anyway, we're just going to keep it 5 times the square root of 3. That's super easy. Would you agree? So you should be able to do a quiz on this, right? If I gave you the short side. But what did I say to begin this? I said that was the easiest problem that we're going to have, all right? It does get a little bit tougher. So hopefully you got this part down, right? If I gave you the short side, you should be able to give me the other two sides with no problem at all. Tell you what, let's change it up just a little bit before I get to the next part. What if I said that this was, I'm going to really test your algebra skills here. What if this was 2 square root of 7? You're like, Mr. Hammer, what kind of number is that? That's a stupid number, right? 2 times the square root of 7, all right? Well, it exists. It's a real number. It's an irrational number, which means it doesn't repeat, right? The decimal, it doesn't repeat, but it just keeps on going. It seems like just a bunch of random numbers afterwards. But let's do this. What's the easiest one to find? Let's do x and y again. I guess it could be. Yeah, let's do the hypotenuse. I think you're probably right. That's probably the easiest one. So what do I do with this? I take the short side, and what do I do to get the hypotenuse? Multiply by 2. Exactly right. Double it. Multiply it by 2. I'm going to do this off to the side. So it's 2 times 2 square root of 7. This is what I mean by I'm testing your algebra knowledge here. Right? If I multiply these together, how do I multiply? Do I multiply the 2 by both of these numbers? No. Okay, no. I just multiply this 2 by what? No, forget the sides and all that. Here's our problem right here. It's just an algebra problem, arithmetic problem. So it's just 2 times 2, which is 4, and then I just put the square root of 7. All right? Everybody see that? That's how I multiply those together. I just multiply those whole numbers together, and I just stick that square root of 7 right there. All right? So what's y equal to then? 4 times the square root of 7. Easy. Just keep it like that. Really, it was just 2 times 2. That was the only thing you really had to do, wasn't it? And then you just kind of throw the square root of 7 in there. What about this one, though? How do I find the long side? I take the short side and I do what to it? I don't multiply it by 2 this time. I multiply it by square root of 3. So off to the side, let's do that. So I'm going to take 2 square root of 7. That's the short side. Now I'm going to multiply it not by a 2, but by a what? Not by a 3. It's a square root of 3. Completely different number. 3 and the square root of 3 are completely different numbers. Now, what in the world do I do with this? Well, we've kind of learned this. I talked about this yesterday. That's right. You put it under one big square root. Everybody see that? When you have 2 little square roots, we'll say, right, multiplied together, you just multiply the 2 numbers and stick them under one big square root. Now, what about that 2, though? The 2 just stays out there. And now what I can do is take this 7 and 3 and put it under one big square root. So that would be 7 times 3. You see that? That's a rule that hopefully you learned in algebra. If you didn't, that's okay, because I've taught it in here several times, haven't I? Yeah? All right, so we're almost done with this. So it's going to be 2 times what? The square root of 21. Okay? And that's it. Okay, that's your answer for the longer leg. It's going to be 2 times the square root of 21. They're weird-looking answers, I agree, but that's what they are. Okay, that's how long that side is. This is how long this side is. You're like, well, I have no idea what 4 times the square root of 7 is. So what would you do to get some general idea? Stick it in a calculator, right? Figure out what it is. So let's, I'm going to get my calculator out on my phone right here. So I'm going to go 4 times square root of 7. Square root of 7 is 2.645, blah, blah, blah. And then I hit equals, and it's about 10.58. Let's round it to one decimal place. So this would be what? 10.58. If I round it to one decimal place, 10.6. So it's approximately 10.6. So what do you think this is going to be approximately? The short side. It's half of this, right? So what's that? Should be about 5.3, right? So let's do it. 2 times square root of 7 equals, 5.29, right? Because remember, this was rounded. 5.29, which does round to what? 5.3. So that works, doesn't it? And then, now whatever that is, the square root of 21 times 2, and that's about 9.16. We'll take that 6, round it up, and so it's 9.2 approximately. Does that make sense? Yeah, the hypotenuse is still the longest side, 10.6. The longer side is just a little bit smaller, right? And that's what it should be. It should be just a little bit smaller than the hypotenuse, and it is. It's 9.2. And the short side should be exactly half of the hypotenuse. Now, again, these are approximations. We've rounded and that kind of thing, but it does work out pretty nice. Make sense? That's what we're finding, okay, with this 30, 60, 90, 45, 45, 90. Why do we need to know this stuff? Because there's a lot of times when people build buildings, they build buildings to with those angles. Okay, you'll see 90-degree angles. Look at this room right here. There's 90-degree angles all over the place, right? Right up there. See where the wall and the ceiling come together? 90-degree angle. Right here in the floor, 90-degree angle. You rarely go into a room or a building where here are your walls and they're slanted. Would you agree? You might go to some crazy museum or something, and they make some kind of fun house place or whatever, and they have it slanted. Or your house is really old and the walls are starting to fall in. Okay, maybe you have that situation. But 90-degree angles are all over the place. Okay, and there's also 45-degree angles that are all over the place, and 30-degree and 60-degree. These are very, very, very popular angles that you're going to see everywhere you go. All right, and so it's nice to know how to deal with these things, and that's why we learn this. Okay, you may not use this your whole entire life. Okay, you may not. All right, but there's a lot of people that will. And that's why we learn this stuff. I get people ask me all the time, Mr. Hammer, why we got to learn this stuff? This is dumb. I'll never use this. The rest of my life, I'll never use this. I'm like, well, you may be right. You may never use this the rest of your life. I'm not going to try to pull the wool over your eyes and say, oh, yeah, there's going to be a time where you're going to need this. You're going to have to learn this. Okay, there may not be a time. All right, but for some of you, there absolutely will be a time. All right, not just to take another class, but you may have to do stuff. I was talking to somebody, did I tell you the story? A former student of mine. He's a man now. He's got kids, and his son is married. I shot his wedding, and that kind of thing. And so, what's that? No, I shot it by myself. So, no, this is not. I have more than just his dad as a former student. Okay, he's not the only one. So anyway, listen, listen. So he's actually an engineer. Well, he got his degree in engineering, and he worked. I probably told you this part. He worked at Boeing. Do you know what Boeing is? They make airplanes and stuff like that. But he actually worked on like Apache helicopters. They're like military helicopters, right? Really fast, really cool helicopters. He worked on those, and I think he worked on the Osprey. I think an Osprey is kind of like a helicopter and a plane together. It takes off straight up like this, and then the wings push out like this, and it takes off like that, like an airplane. Anyway, he worked on that stuff. He told me the other day I actually shot an event for his son. His son is now into video and photography, and he actually booked an event, and he hired me as the photographer. And so I'm actually working for my former student's son now. It's crazy. So anyway, he said he was doing something like in the garden or something like that, and he said he actually used Pythagorean theorem because he wanted to cut, like a flower bed or a plant bed. I don't know what you call them. I'm no gardener. I don't know. But anyway, he wanted to cut this stuff. He wanted to figure out how long that one side should be. And he says, oh, yeah, I used Pythagorean theorem, and I did all this. And he said he even used 45, 45, 90 triangle, and he used a 30, 60, 90. He told me this all by himself. I didn't go to him and say, hey, have you ever used geometry? No. But I taught this kid geometry when he was in high school. But he was so excited about it, he came to me, and he didn't say Mr. Hamrick. I was about to say Mr. Hamrick because we're like friends now, the dad anyway. And so he called me Aaron. So he's like, Aaron, I got to tell you what I did. I used this, and I thought it was pretty cool. I thought that was neat. So there are times when you could actually use this stuff. All right. Yes, sir.
Does anybody ever call you Aaron?
No, just when people are just making fun. But I've seen the skit. I know it. It's a pretty funny skit. I'm good with that. Aaron. Say what? That skit's not bad. The Aaron with all the names. No, that's hilarious. No, that guy's funny. I like it. What's that guy's name?
I think it's like Keel.
Oh, he's the Key and Peele. Yeah. It's the one that's not the because the other guy's like a movie director, right? He's like a serious movie director now. Yeah. Yeah. My kids used to watch him. Didn't they have like a kid show or something like that? No, I don't know. I can't remember. All right, let's do this. Here we go. You need to solve for X and you need to solve for Z. Let's do it. I'll give you like a minute. Now, this is a little bit tougher. Okay, but what I would do is this. Did you write these two things down in the boxes? I would write them down, especially this one right here because it's a 30, 60, 90 triangle. So the long side is equal to square root of 3 times the short side. So write that down. I'll help you out. So the long is equal to the square root of 3 times the short. So what are you going to solve for first here? The short side. Which one is the short side? How do you know? Just because it looks like it? Because it's opposite the 30-degree angle. That's right. I should put degrees right there. There you go. So plug the stuff in. Actually, I'm sorry. We're not going to use that one. We're not going to use that one first because I don't know the short side and I don't know the long side. So you can't really use that one, can you? Not yet. We're going to use it later. But you can use this one. The hypotenuse is what? Twice as big as the short side. So finding this one is what we're going to do first, the short side. And that's pretty easy. Well, actually, I'm sorry. I lied again. That's a little bit tough. So I was right to begin with. How dare did I think I was wrong? It's because I'm wrong a lot. That's why. I'm not that smart, believe me. All right. So this is what we're going to use right here. So which one of these do you know? I said it incorrectly. I said you didn't know either one of these, but you do. just because the triangle looks a little different than I'm used to. You know the long side, that's right. Okay? How do I know that this is the long side? Because it's opposite the 60. Okay, everybody see that? So what we're going to do is plug stuff into this little formula right there. So what's the long side? It's 12 equals, let's do the rest of this formula. What is it? The square root of 3 times the short side. What's the short side here? And now what are we going to solve for? Solve for x. That's right. So how do we do that? What do we do to the square root of 3? It's being multiplied. How do you get rid of something that's being multiplied? You divide it. That's right. So I divide it by the square root of 3. Now, we come up with a little bit of an issue. Remember we talked about this yesterday? Yeah, okay. We have to get rid of that. So that cancels. Now watch carefully. Watch. Come on. We're right in the middle of it. Come on, come on. Does everybody see how we set this up? I use this formula. It's in a box, right? There's the long side. If you want, I could write it up here. The long side is equal to the square root of 3 times the short side. All right, so the long side is 12, so I put a 12 there. I put the square root of 3, and then the short side was x, so I just put an x there. Yes? Say that one more time. 12 by 2? No, because this is the long side. If I knew that the hypotenuse was 12, then you'd be absolutely right. But this is the long side. This is like the hardest version of this problem, okay? So they don't tell you the hypotenuse. If they did, if they told you the hypotenuse, then you could do what you said, okay? You could divide by 2 to get this. But remember, this is the square root of 3 times the short side. So we don't divide by 2, we divide by the square root of 3. Does that make sense? Okay. But this is okay, I guess. But remember what I said is not good about this? What don't we like about this answer? 12 divided by the square root of 3. That's right. The square root's in the bottom. Remember we talked about this yesterday? Review the lesson. Okay, we said you can't have the square root on the bottom. So what do? Well, almost. Multiply, right, by the square root of 3 over the square root of 3. What allows us to do that? Because I did this in yellow for a reason. Why? Nah, that's not why. Because what's anything divided by itself? I remember specifically standing here yesterday. It's 1. That's right. It's equal to 1. Can I multiply anything by 1? Absolutely. I don't ever change the value, do I? If I take a number and multiply it by 1, I've never changed the value. So I'm allowed to do this because all I'm doing is multiplying by a 1. You see it? But what it does, why did I do it then? If I just multiply by, I could go to anything and multiply by a 1. But why did I do this? Because what happens when I go square root of 3 times square root of 3 on the bottom here? Well, they kind of cancel out. So what am I left with then? Just a 3. So the square root of 3 times square root of 3 is really the square root of 9. What's the square root of 9? It's 3. Okay? You see that? Now, if I multiply the top, what do I get? 12 times the square root of 3. We're almost ready to give an answer on this one. But look at this 3 and this 12. It's just a regular 3 and a regular 12. So, right, 3 goes into 3 once, 3 goes into 12 4 times. So what's the best way to write what x is? 4 times the square root of 3. That's the way math teachers want you to write that answer right there. So you did divide by a square root of 3, but we don't like the square root of 3 on the bottom. There's reasons. Don't worry about why. People just don't like it, okay? So that's all we're concerned about. So what do? Multiply by top and bottom by that denominator, which is square root of 3. That gets rid of the square root. Okay, that way I don't have a square root on the bottom anymore. I can have a square root on the top. It's fine. Just can't have it on the bottom. Make sense? Now, that was the hardest part of that whole problem. Now, to solve for z is actually pretty easy. Z is the hypotenuse, isn't it? Okay, look at my formula right here. Hypotenuse is just twice the short side. Well, what was x? X is the short side. So how do I find the hypotenuse? Take the short side, multiply it by 2. So it's 2 times 4 square root of 3. Should be able to do that now. You just go 2 times 4, which is 8, and then you just keep the square root of 3. So that's what z is equal to. So there's your answer for x and z. What do you think? It really doesn't get a whole lot harder than that right there. It really doesn't. Okay, that's about as hard, at least for you guys anyway, that's about as hard as this problem's going to get. So if you can handle something like this, you shouldn't have any problems with 30, 60, 90 triangles. That's about the hardest that problem gets right there. We good? Let's do one more.
Yes.
Now this is where it becomes practical. All right. Let me draw triangle. Oops. There we go. Let's put 3 sides on this. There we go. Why does it still do that? That's right. Woo, look at that. Okay. And let's grab it right there. Now this is an equilateral triangle. Anybody remember what equilateral means? All the sides are equal, which also means the what? The angles are going to be equal to each other as well. Now, we had a thing, I guess, can't think of any better way to say it. We had something that we learned that if we did this, watch. We learned this a while back. You may not remember it because we haven't talked about this in a long time. But if I took a perpendicular line from one of these vertices, this one up here, if it's perpendicular to each other, what do you think it does to that triangle? Bisects this angle, right? So this angle and this angle equal each other, and it makes a 90-degree angle. It also does what to the length of the side? It cuts it in half, okay? So we learned that. There's a theorem, postulate, I can't remember. It's something that we learned a while back. Now, if this was equilateral, remember what you just said earlier? You said if it's equilateral, it's also equiangular, which means all 3 of these angles of that triangle are equal to each other. So we should know what the degree measure of all 3 of those are. So if I know they're all equal to each other, what do they all add up to be? All 3 angles, 180, right? It's a triangle. So if all 3 angles are exactly the same, how can I find what each of the angles actually are? Divided by 3, that's right. So take 180, divided by 3, what's that? 60. So that means that this is 60, this is 60, and this big angle up here is 60. But remember what we said about this perpendicular line. What does it do to that big angle right there? It bisects it. So what's this little skinnier angle right here then? It's 30. Guess what we have? We now have a what? 30, 60, 90 triangle. Okay? You with me on this? All right. What we're going to do, now watch. You're going to look at this, you're going to be like, where did that come from? I thought we already finished the chapter on area. But they ask you to find the area of this triangle. If this is 5, of course, all 3 sides are going to be what? 5, because I said it was an equilateral triangle to begin with, okay? So if that's 5, and then what's this right here? This whole side is 5, so what's this little bit from this part right here to this part right here? 2.5, that's right, okay? I don't even think we're going to need it, but if you wanted, you could, let's just do it. Yeah, we know that's 2.5. Would you agree? Now, the question says, find the area. Yes. You have a math question? Somebody ask me a math question, all right? Just make me feel good about it. What's a math question? Yeah. Trent, tell me.
When you're doing this,
Say go.
do you need to find the long side of the...
That might be a good idea, okay? Because we're finding the area. Thanks for that great question. I appreciate it. So we want to find the area. Now, it's a triangle. So do you remember what the area of a triangle is? You should remember that. It's 1/2 the base times the height. Okay? You with me? Now, What is the base of this whole entire triangle? It's 5, right? From here to here is 5. All right, so let's put some stuff in. So it's 1/2 times the base, which is 5, times the height. Which one is the height? It's the perpendicular one. The one goes up and down, right? We'll call it h for height. Okay? Now, it's not hypotenuse. That could be a problem. What's the hypotenuse on this right triangle right here? It's 5, right? Okay? So now, what can we do? We already figured that's 2.5, right? Remember that? So how could we find that? So let's kind of do this off to the side. We'll do it right here. So what's the height? It's a 30, 60, 90 triangle, correct? All right. So this is the longer side. So how do we find the longer side? Look at your formulas if you need it. It's the square root of 3 times the short side. The short side, okay? It's the square root of 3 times the short side. Do I know the short side? Do I know the short side? Yes. It's 2.5, isn't it? Agree? All right. So what is the hypotenuse? It's the square root of 3 times what? 2.5. Okay? And we're just going to write it like that in here. So bear with me. Here we go. We're getting there. I know I lost a bunch of you already. So it's just 2.5 times what? Square root of 3. All right? And let's see. How do they do this? Yeah, they just leave it square roots. They don't put it into any kind of thing here.
No.
So let's see. Let's do this. How do we do this? This is all over 2, isn't it? We're almost done. So watch. Somebody do this for me. What's 5 times 2.5? Should know that. 5 times 2.5. It's 12.5. So watch. It's 12.5 times the square root of 3. Did I do that right? Yeah, that's right. Yeah, it's technically not really how you want to write the answer, but I'm okay with that. The reason is, here, I'll show you why. Trent, look. All right, you guys can go. So watch. I wrote 2.5. It would have been better if I would have just written it 5 over 2 instead of writing it as a decimal. Okay? So now watch. So what we have here is 1/2 times 5 times 5 over 2 times the square root of 3. You see that? It's just better to write it not as a decimal. You never want to combine decimals and fractions together. So look what happens here. 5 times 5 is 25 over 2 times 2, which is 4, square root of 3. That's the way that they want you to write it, like that. Okay? I would accept this. All right? But this is the way that they want you to write it. We good? Okay. Oh no. Oh. I thought I wasn't recording, but I think I am.
Oh, no.